Alright, now we're on the Chapter 9 study guide of the no calculators. So no calculators are allowed in this section. So here we go. Number 1 wants to know the number of real solutions of each equation. So there's a few different ways to do this. So for number 1, the first thing I see is that I have just x squareds. So all I have to do is just play the game of opposites. So to get rid of that 8, I'm going to divide by 8. 0 divided by 8 is 0, so 0 is equal to x squared. Then from here, I would take the square root of both sides. And when you solve for a variable, you have to account for the positive and negative. But here's the thing. For 0, there's no such thing as the positive or the negative. 0 is neither positive nor negative. So therefore, x can only be one number, 0. So therefore, it is just one solution. Number 2, again, I just have x squareds, so I can play the game of opposites. So I'm going to subtract 9. So negative 9 equals 4x squared. Get rid of the 4. I'm going to divide by 4. So I get negative 9 fourths equals x squared. I'm going to take the square root, and all of a sudden we have a problem. Can't take the square root of a negative, so this is no solution. Now number 3, I got to go through the full process. And on 1 and 2, you could have done this exact same thing, but I just knew it was quicker to do it this way. For number 3, though, because we have x squareds and x's, this would be using the quadratic formula. But you don't have to do the whole thing, because the only thing that's going to determine how many answers you have is that square root part, which we call the discriminant, the b squared minus 4ac. Again, that's the fancy name for that is the discriminant. Because if you get a positive number under the discriminant, that means you have two answers, because you have the positive and the negative. If you get a negative under the discriminant, negative as your discriminant, you can't take the square root of a negative, so you have no answers. Or if you get a 0, well, the plus minus doesn't mean anything, because the square root of 0, there's only one answer, 0. It's neither positive nor negative, so you get one answer. So you could have done all that up here, except you didn't have a b value in this one, or c. That's okay, you still would have gotten the right answer. So let's try it on number 3. So a is negative 3, b is 1, and c is negative 4. So here we go. B squared. So this is going to be 1 squared minus 4 times a, which is negative 3, times c, which is negative 4. Order of operations, we do exponents first, so 1 squared is 1. Now here again, this is where I like to multiply and consider this a negative. So negative 4 and a negative 3 make a positive 12. 12 times a negative 4 is a negative 48. So since it's a negative answer, I write it as minus 48. So now we do 1 minus 48, which is negative 47. Remember, this is all under square root sign. So once you got to this point, you can't take the square root of a negative. So again, this would be no solutions. All right. Perfect squared trinomial. Remember, a perfect squared trinomial is of the format a squared plus 2ab plus b squared. You might be going, well, what does all this mean? Well, this means that your first term and your last term are perfect squares. Like 9, 16, 25, because the square root of those numbers are whole numbers. 7 wouldn't work, because the square root of 7 is not a whole number, so therefore it's not a perfect square. This 2ab, what does that mean? Well, that means this middle term is double the square roots multiplied. So once you find the square root of a squared and the square root of b squared, you multiply them and double them to get the middle. That's how you know you have a perfect square. So for example, x squared plus 16x plus 64, that's a perfect square trinomial. The square root of x squared is x, square root of 64 is 8. So if we multiply 8 and x, we get 8x. Now if we double it, we get 16x, which is what we have here. So that's what makes a perfect square trinomial. So when you have to come up with the missing number, this is called completing the square. And the shortcut, or the process, is you take half of your middle term, So the middle term here is 10, so we take half of it, and then you square it. So 10 divided by 2 is 5. 5 squared is 25, and that's your answer. Could we check it? Sure. Square root of p squared is p. Square root of 25 is 5. So like we did over here, we multiply our square roots together. So 5 and p make 5p. Double it. 5p times 2 is 10p, and that's exactly what we had to have in the middle. Do you have to do that every time to check? No, but I'm just proving that it does work. So number 5, let's do it quickly. We're going to take half of that middle term. So negative 60 divided by 2, which is 30. Then we're going to square 30, and we get 900. Okay, so now we're going to use this completing the square method to actually solve some of the questions. So what we want to do is, let me get this set up better. We want to complete the square, because that's what it tells us to do. So to complete the square, we want to make it look like a perfect square trinomial. So we have x squared minus 18x. Well, we do what we did just a second ago. We need that nice perfect square number here. So how do we get it? Well, we take half of negative 18, and then we square it. So that's going to be negative 9 squared, which is 81. So I put a plus 81 here. Now that 81 was not part of the original problem, so we have just made the left-hand side heavier. So we have to do the exact same thing to the right-hand side. We have to add 81. So now I have x squared minus 18x plus 81 equals 100. Now the whole point to complete the square is now you can factor it. We could use a diamond. What two numbers add to give me negative 18, multiply to give me 81. Or the shortcut is you just take the square roots. It always works. That's why completing the square is a useful problem, because you can just take square roots to factor. So the square root of x squared is x. Square root of 81 is 9. There is a minus sign in the middle, so I use a minus sign in the middle of mine. So x minus 9 squared is equal to 100. Now we solve. Game of opposites. How do we undo squaring? Take the square root. So I have x minus 9 equals, remember we're solving for a variable, so square root, there's two answers, positive and negative. Square root of 100 is 10. So x is equal to, we add the 9 to the other side, and I like to put that whole number first, before the plus minus, so that's going to be a plus 9, so it's positive. So it's 9 plus or minus 10, which we can actually do. So we do the first one. 9 plus 10 is 19. 9 minus 10 is negative 1. And those are your two answers. Number 7 is a little bit different because you've got a 4 in front. So there's a few different ways of doing this. One way is you can divide every single thing by 4, so you don't have that leading coefficient. And that's great when you're solving for variables. So I think that's what most people have been having the most success with. So let's try it that way. So I'm going to divide everything by 4. So 4 divided by 4 is a squared. 8 divided by 4 is 2a. Negative 20 divided by 4 is negative 5. 0 divided by 4 is 0. Now we can complete the square, except for the problem that this guy is in our perfect square spot. So we're going to have to move him over. So we're going to have a squared plus 2a. To get rid of that minus 5, we're going to add 5 to the other side. So it's going to be a positive 5 now on the right. Now we complete the square. So we take half of the middle term. Middle term is 2. Half of it's 2 divided by 2, and then we square it. 2 divided by 2 is 1. 1 squared is 1. So we put plus 1. That's a brand new number, so the right side needs it to balance out. So now I've got a squared plus 2a plus 1 equals 6. Factor by taking square roots. So we have a plus 1 squared is equal to 6. Or you could have done a diamond. It works there as well. Just a's now, so play the game of opposites. Take the square root, a plus 1. Now remember, we don't have a calculator, so we can't tell someone what the square root of 6 is because it's not a whole number. So we just put plus minus root 6. Now we just got to get a by itself, so subtract that 1. So a is equal to -1 plus minus square root 6. Or if you wrote plus minus root 6 and then your minus 1 after it, that's acceptable as well. In Algebra 2 they won't accept that, but for now it is okay. Okay, for 8 and 9, we are changing from standard form to vertex form. Remember, you could do the cheat code way that we did on the state exam, where you do negative b over 2a to get your x of the vertex, plug it in, use the order of operations, and then make sure you write the vertex form the correct way. Or we're going to do this much quicker. We're going to complete the square. So that minus 32 is in our way. So this is going to be f of x plus 32 equals x squared plus 40x. So let's complete the square. So we're going to take half of 40 and square it. So that's going to be 20 squared, which is 400. So we put a plus 400 on the right, balance it out by putting it on the left as well. So now we have f of x plus 432 equals, now the whole point of completing the square is so you can factor. So let's do it. Take the square root of x squared, which is x, square root of 400, which is 20. We got a plus sign in the middle, so we use a positive. So that's x plus 20 squared. So that's almost vertex form, except we don't have f of x by itself. So let's just subtract 432 from both sides. And by doing that, you're now in vertex form. And we did not have to do any order of operations, plugging in of values, so it's much quicker to do it this way. But if you're still not comfortable with it, then do it the old way that we've done it in the past. Here we go again. We are going to complete the square. So let's subtract 23. So y minus 23 equals x squared plus 9x. The only thing that's going to be hard about this one is a fraction. So let's take half of the middle, square it. So 9 halves times 9 halves gives you 81 fourths. So I put a plus 81 fourths, put a plus 81 fourths. So here's where people don't like to do this, because they got to use fractions. So we have to do negative 23 plus 81 over 4. So that's negative 23 over 1 plus 81 over 4. We need common denominators. So common multiple of 4 and 1 would be 4. So I don't need to change the 81. But I do have to change the 23 because I multiplied 1 by 4. So the negative 23 has to be multiplied by 4, which in this case is going to give us negative 92. Negative 92 plus 81, that's going to give us a negative 11. So negative 11 fourths. Not too hard. So y minus 11 fourths equals, whole point of completing the square was to factor. And this is where the diamond, you don't want to do the diamond anymore because it's too hard. This is where you want to know the shortcut. So the shortcut is take the square roots of the first and the last. Square root of x squared is x. Square root of 81 over 4. Square root of 81 is 9. Square root of the 4 is 2, so it's 9 over 2. Plus sign from the middle. Remember, it's squared when you're done. Now move that minus 11 fourths to the other side. So we get x plus 9 halves squared plus 11 fourths. Could you have gotten this by using the negative b over 2a and then doing substitution? Sure. I'm not going to do it that way because it takes longer, even though you might think that this takes longer. But really, if you're comfortable with fractions, this just took longer because I explained every little step, but I would never be explaining all this. I would just be doing the fractions quickly. All right, on to number 10. These, we are solving each equation. Keep answer in root form if necessary. Not every answer is going to be in root form. First one's nice. It's already been factored for us. So this says the first parentheses times the second parentheses gives you 0. Well, if you multiply and your answer is 0, you had to multiply with the 0 at some point. So it was either the first parentheses that turned us into a 0. So let's see what x would have been. So if x minus 5 was our 0, what would x had to have been? Well, solve for x, so we add 5 to both sides. So 5. 5 minus 5 is 0, so that would have turned this whole equation into a big 0. But maybe it wasn't our first multiplier. Maybe it was our second one, the 2x plus 1. So if the 2x plus 1 was our 0, let's figure out what the x was. So we subtract 1 from both sides, divide by 2, negative 1/2. So these are the two different answers that, if you plug in, give you a 0 as your final answer. 11, we got to do a little bit of work. X squareds and x's. Anytime they're mixed together, the equation must equal 0. So let's make it equal 0. So let's get rid of that 10x. So let's subtract 10x. So then we have a vacant spot over there, which is just a 0. So x squared minus 10x equals 0. Again, we have three options. Factor, complete the square, or quadratic formula. Well, this is really easy to factor, so let's do that. This has a GCF. The GCF, and someone might go, well, there's nothing that goes into 1 and 10 as well. Remember, variables can be GCFs as well as numbers. So they both have at least one x in common. So that's what we're going to pull out. I'm sorry, they have at most one x in common. So that's what we're going to pull out. So this is going to be x parentheses. When you pull out a GCF, your new parentheses becomes your equation divided by what you pulled out. So x squared divided by x gives you x. Negative 10x divided by x gives you negative 10. Now we're set up just like over here. Either this or that gave us a 0. So if x gave us a 0, well, that's done for us. X just has to be 0. Or it could have been the x minus 10 gave us the 0, which in this case, x would have to equal 10. So we got our two answers. All right, number 12. X squared and x's, we go back to that statement that the equation must equal 0. So let's add the 12 over. So x squared minus 7x plus 12 equals 0. So now we're going to try to factor. Find two numbers. This would be a diamond. Two numbers that add to give you negative 7, multiply to give you a positive 12. So diamond people, this is what your diamond looks like. Well, if you multiply to get a positive and add to get a negative, they both have to be negatives. And two numbers do work, a 4 and a 3. Negative 4 plus negative 3 is negative 7. Negative 4 times negative 3 is positive 12. So this is x minus 4 times x minus 3 equals 0. So here we go. This times this gave us 0. So either this was 0, our first parentheses. So x minus 4 is 0. That means x would have had to have been a 4. Or this multiple was a 0, x minus 3, which means x would have had to equal 3. So far, even though this is in the calculator section, haven't really used the calculator. Actually, this is no calculator, never mind. All right, number 13. We've got our equation. It equals 0. So we've got options: factor, complete the square, and quadratic formula. So since we haven't done the quadratic formula on this one, let's use the quadratic formula. Because it's not going to be factorable. It can't be factored. So again, your quadratic formula will be given to you on the day of the test. So a is equal to 6. That's our first number in front of x squared. Our second number in front of x is our b value, so negative 18. And our c value is negative 1. So here we go. So negative b, so it's going to be 18 plus minus square root b squared. So that's going to be negative 18 squared minus 4 times a, which is 6, times c, which is negative 1, all over 2 times a, which is 6. And so yes, I know this is in the non-calculator, and so yes, you're going to have to do a little bit of 4th grade double-digit multiplication to get your answers. So here we go. Order of operations, we're going to do negative 18 squared first. So we're going to do 18 times 18. 8 times 8 is 64, carry our 6. 8 times 1 is 8, plus 6 is 14. Move over to the 1s, we got to put our 0 in. 1 times 8 is 8, 1 times 1 is 1. Add, so 4, 8 plus 4 is 12, carry our 1, 324. So now we've got our 18 squared, so it's going to be 324. Now we do this multiplication. Negative 4 times 6 is negative 24, times negative 1 is positive 24, which gives us 348. And so from here, we now have 18 plus minus square root 348 over 12. And if you leave it like this, let's see, can we simplify the square root of 348 using our radical forms? I think we can. So if you leave it like this would give you half credit. But what we can do is 348, that square root can be broken down. So you can use a factor tree if you want, or the perfect square method. I'm going to use the perfect square method. I see 348, I'm pretty sure 4 is going to go into it. So let's check. So 348 divided by 4. 4 goes into 34. 8 times, you'd have a remainder of 2, so that becomes a 28. 4 goes into 28, 8, 7 times. So yes, root 348 is equal to the square root of 4 times the square root of 87. Well, the square root of 4 is 2, so it's 2 root 87. And looking at 87, no perfect squares will go into that, so that's as far as you can take it. So what we now have is 18 plus minus 2 root 87 over 12. If you left it like this, I'd take off 1 point. But if you can see, your whole numbers, or your regular numbers, 18, 2, and 12, they're all divisible by 2. So we need to do that. So 18, this is reducing your fraction. That's what we're doing here. 18 divided by 2 is 9. 2 divided by 2 is 1. So you can put a 1 in front. You don't have to, though. And 12 divided by 2 is 6. So this would be our final answer. And then we end up with a much easier question, number 14. You only have x squareds, so you can factor if you want to, or just play the game of opposites. So add 81 to both sides. Now we take the square root. Because we're solving for a variable, we have to account for the positive and the negative, and the square root of 81 is 9. And that is the end of the non-calculator part of your study guide.